Hello, I'm coming back to you with another video, binary tree level order traversal. This is a medium problem, our first medium problem in trees. Well, let's get it. This is going to be our 59th problem. Oh my goodness, we're getting there. We're gonna have to still redo all of these, I think, to get a better understanding and make sure that we know what we've learned and we learn it better. This is called spaced repetition, so always work on it and work on it again. Anyways, here's a binary tree level traversal. It's basically going through line by line. This is basically breadth first search. In that sense, we're gonna have to do a queue, set it to empty array, set it to the root. One thing to note is that if it's a empty, we'll figure it out. If the root is not root, let's return empty array, but we might have a way to fix that a little bit later. So one thing is that we're gonna have a current level so that we record our information as an empty int array, and we need our next level, so to store everything that's going to be in our queue, because what's going to happen is we're going to do a while queue, and what that means is that we're going to go until the queue runs out of items. And the way to do that is we're going to keep looking for items, and we're going to store everything in the next level. So next level dot append. So let's set the node first. Node equals queue dot pop 0, the 0th item. And once we pop the 0th item, that's the front of the queue. So first in, first out. Once we pop the 0th item, let's just send it out. So what that means is that current level dot append node dot val. The thing is, if this is not this node is empty, if node, I think that is what we need to do. That's the one thing we can do to eliminate that line of code. So then node dot left, and we can append next level dot append node dot right. So we append everything to the next level, and if not queue, so basically run out of items in queue, queue is going to be equal to next level, and the output is gonna output dot append the current level, and we reset the current level to empty array so that we can reset the next level, so we can start repeating the same process over and over again. And I think that's it. We don't need this line of code anymore. And I think that's it. Like return the output. After we're done, we should have the right answer. Let's see. Looks like we have an extra empty array here. So that didn't quite work. If current level but that would remove the option of an empty array, even though that would work here. It would not work in this particular case where it's completely empty. Watch. Oh, it did work. Huh. Okay, well, let's submit it. Let's see what happens. Wow. Oh my god. Okay, well, that looks like it solved the problems. All the problems, and we got a pretty fast time. So essentially, make a queue. If the node exists, append, and if nothing in the queue anymore, then we create the next level and we keep going. Yeah, that's all. Pretty simple. Yep. Anyways, with that, there is another way that Neetcode does this, and the way he does it is that he uses the queue length and he uses a different data structure called a DQ. Let's do that right now and get a little bit more practice in and see his way of doing it, rather than using a current level, just store the current level and appending it and using the next level. So his way is set the he set the output to empty array, and we're gonna do a queue, which is DQ, and the queue is gonna append the root. We're gonna do a while queue as well, but the difference is that we're gonna do a queue length, which is a length of queue, and we're gonna create levels here instead. So this is gonna have a double loop. Instead of filling things up, we just go straight through the items, the number of items in the queue length. And so node equals queue dot pop left, if node level dot append, same thing as what we did earlier, queue dot append node dot right left, queue dot append node dot right. And once we're done, if level output dot append level, and we keep going until the end, and that's it, and we return the output. So I don't know what you think is cleaner. They might be all very clean, but this way is definitely a little bit slower for some reason. Maybe it has more logic in it, and this has less logic. Yeah, but yeah. So both ways work. One that does remembers the length of the array, and that have a double loop, and one just doesn't have a double loop, but rather just saves the items and inserts it when it's available, when it's needed. Yeah, I like that. I think I like the bottom one more, but if you do need the second one option, we do have that at your disposal. Anyways, if you enjoyed this video, please like and subscribe. If you want more videos, check the link in the description below, and I will see you in the next one. Thank you very much.